In this 13-minute video, we're going to go over how to check a fuse. I'm going to help you guys understand how fuses work and why they're set up the way they are. We're also going to go over basic uses of a multimeter. Please watch at least 30 seconds of this video. I'd really appreciate it. Got this little control panel here. Don't worry, it's dead. Right here I got a fuse block. Hey, if you need to pull a fuse out of a hot circuit, this is the device used. It's called a fuse puller. Stick that bad boy in there, grab it, and yank. Remember, you pop it out. Set your meter to ohms. You want to make sure your power is isolated. That's very important. Maybe get a voltage tester pen. Best way to do it is a multimeter and just poke around in the panel. I don't know if you could read that. 0.0 ohms. So when you check your fuse, this fuse here is basically just a piece of wire that's pretty thin. And this piece of wire inside of here is set to pop open at a certain amperage that's known, and that's how you get your fuse rating. So that's how I test my fuse with no power. Pop it out, put it in your hand, test it on ohms. Ohms is electrical resistance. It's just a little piece of wire, so it has almost no resistance. You want to be aware of the units. A big M is million. Little K is thousands. So if you do your resistance reading, you see 0 ohms or 10 ohms, you're good. If you see something in the kilo ohm scale or the mega ohm scale, that's a blown fuse and you got to replace it. Any corrosion on the edge of your fuse is going to cause a higher reading. You can also measure the functionality of your fuse with the power on, so I'm going to review that next. So this little panel I'm using, if we're using industrial schematics with something like this, you got line 1 coming in, it's 120 volts, and this particular fuse goes through some float switches, which we're not really reviewing in this video. It's something I used for a previous video. And then that fuse goes up, that circuit goes out, and it turns on a relay. Okay. Then when that relay turns on, it energizes a motor. And in this video, I want to review, how much current do we need for this, and how would we fuse just this circuit, and how would we fuse just this circuit, and how do you figure it out? But getting a little ahead of myself. So right now I don't even have the motor installed, but I got a fuse right here. I don't know, let's call it a 1 amp fuse. I don't even know what it is, but that's what we'll call it. And I'm going to show you guys how to test that with the power on. Can't forget, that's your symbol for ground. Ground is usually tied to neutral. Let's go. So right now, I said I was going to review basic functions of a multimeter, so let's go ahead and do that. If you're working with AC voltage, you want to look for the volt sign with the squiggle on the top. If you're running DC voltage, you look for the voltage sign with the line on top. And these two leads, they're comparing 2 points. So I can't just hit one thing and measure it. I gotta compare it. So I go to volts, AC. Whoop. So I go to volts, AC. See, look at the unit, volts, 0.3 volts. I'm just measuring the air, I don't know. Let me go to neutral. It's one side of my plug to the hot side of my plug. (121 volts). Then I got my fuse right here. My circuit breaker is turned off, so I'm going to turn the circuit breaker on. Let there be light. And this is how you measure a fuse with the power on. Again, this is dangerous. Always works. Okay, so I'm on volts AC because I'm using AC voltage. I'm measuring voltage at the top of the fuse block, 100 volts. Then I go down after the fuse. Still got 120 volts, so I know this fuse is intact. I don't know if you guys saw that fuse. That's a slow blow fuse. Put one lead to neutral or ground, other lead to hot on top of the fuse and on the bottom of the fuse. And again, if we're not comparing, then we don't get anything. I just got an arbitrary random reading right there. These are float switches that control a tank that constantly fills up with water, and when it gets too high, it pumps down. And then, oh, here's how it works. So this is the low level float that turns up, and then that one goes up and turns on. When high level float turns off, it still runs. Then when that one turns off, it resets the cycle. Let's go back to our picture here. This is all fine and dandy. This would work fine. We run a fuse that, protects this circuit and this circuit. But what if we also wanted to monitor for high level? So we'll put a high level float, call it high, and that float turns on, I don't know, an alarm buzzer to say, hey, run over here, we got a high level. Then what happens if we have a problem with this motor and this circuit goes bad? It's going to blow that fuse. We're going to lose all the different circuits. So that's not going to work. So in this situation, well, I actually kind of drew it wrong, but basically what we would do is we would have the high level alarm up here with its own fuse. You know what I mean? We put another fuse here that covers relay 1 and the motor. Boom, boom, boom. Neutral, tied to ground. So, yeah, sometimes you can use 2 fuses. So now I just want to review with you guys. Basically, I'm going to have you understand what we're looking at here and how much current is going to flow through each of these and their relationship to each other. I told you guys it was going to be like a 6 or 8 minute video, and I promise you I'm going to stick to my word. We need fuses. Fuses stop fire. So without further ado, let's go to the slide. Short circuit happens when you got, your hot, your 12 volts or your 120 volts. If it gets out of the path that it's supposed to be in, because as we all know, that hot voltage wants to escape. We've all been buzzed up a couple times, at least I have. That voltage is trying to escape, and if it escapes through a path with very low resistance, aka a short circuit, if you give it a path to escape, it's going to escape, and it's going to draw super high amperage because there's no resistance to flow of current. High amps equals high heat, which equals fire. Let's say, God forbid, this wire right here, I should probably turn this off for safety. This wire right here, it's our hot coming in, and then it's going over to the float switches or whatever. If, one of these float switches, let's say this got cut right here. That wire's cut open now, and that 120 volts can escape. That's what a short circuit is. And without proper fusing and circuit protection, it's going to catch on fire. So then we look at another circuit. All those devices are going to have a fixed amount of current that they draw, and you can just add them up. So let's say this relay runs 0.5 amps. This motor runs at, 2 amps. And this thing runs at 1 amp. I don't know. This is getting messy. 1 plus 2 plus 0.5 is 3.5 amps. So they just add to each other. So you got to protect accordingly. You always want to leave a little leeway in your circuit, in your fusing. A few different types of fuses and circuits. You got your small industrial glass fuses that are generally used for motor controls or low amperage and low voltage under 250 volts. You got your 600 volt or 1000 volt motor power fuses. And then also you got your automotive fuses. Obviously we usually run 12 volts on those. And again, they all run the same exact function. They're all just a piece of wire. They're a weak point in your circuit. They're all designed to reduce fires. And then, if a piece of equipment is failing, it's going to reduce the amount of damage if you, catch it quick with a fuse. You blow the fuse, turn off that circuit. And then, depending on how you set up all your other fuses, you can lose one device and still, run every other device in your circuit, if you isolate them with proper fusing. I guess it would be wise to tell you guys how to measure amperage. It's going a little bit out of, basics, but we'll go over it. So on a multimeter, generally, this clamp is used for amperage, and normal, meters, most clamp meters measure amps, AC. So we got AC voltage supplying this, so we can measure the current See here, I'm going to turn this on again. Danger, danger. It's on. All right, so what I'm going to do is spin my wheel to amps. See the squiggle? I can put it right here. This is the coil that turns on my relay. You can see right now it's at 0 amps. When I turn on my relay, see 0.005 amps, which I believe is 5 milliamps, 1/1000th. Then when I turn off my relay, it goes back down to 0, and that's just because I don't have anything turned on this circuit. I don't have my motor attached to whatever. But that's how you measure amps AC, is with your clamp. And they do make DC amp clamps, but they're generally more expensive. Most people don't have that. And when you're measuring amps, if you don't have a clamp, what you got to do is you actually got to, put this in series with your circuit. So I'd have to with the power off, I'd unscrew that wire and stick this lead into that hole. Then I'd take that wire and I would attach it right here. Then I'd turn it back on, and that current would actually flow through my meter, which is, obviously inconvenient. So most people just use clamps. But when you start working with AC, the resistance and the amperage isn't necessarily correlated. And I'm not going to teach you guys that because that's some higher level stuff. And honestly, I don't even really know how to figure that out. But it's usually rated. So usually with a motor, you're going to have a plate on there that will tell you the current rating for a full load. And, going through a motor, the current does change a little bit depending on, if it's kind of stuck or if it's spinning freely. But just figure I bring that up. For some devices, it will tell you the amperage rating. Always go off that when you have the opportunity. Anyways, just to review, we went over how to check a fuse with the power off. You go ohms, top to bottom. How to check a fuse with the power on. You go to ground or neutral and check one side and then compare it to the other side. You want to see the same voltage. We talked about short circuits, which is when your hot wire escapes and causes huge levels of current, which you need to stop immediately. Different types of fuses. Yeah, and then just remember, when you know your current in parallel branches, if you want to know the total current, you just add them up. There's a lot you can do to troubleshoot using, all of that. Current. I mean, that's what we do. We measure voltage, we measure resistance, we measure current, we find a problem. But for this video, I think that's enough. I hope I got under the 8-minute mark, and I really appreciate you guys for watching. Take care.